So for our next problem, number 4, about addition of vectors is an ultimate frisbee player is running at 7 meters per second, then throws a frisbee at 30 meters per second at an angle of 47 degrees with the horizontal. So we're gonna again represent that into the Cartesian coordinate plane here. 1, 2, here. North, west, east, and south. Now it's running at 7 meters per second. So that vector would, immediately be 7 meters per second to the east right here. Throws a frisbee at 30 meters per second at the angle of 47 degrees with the horizontal. So basically that's 30 meters per second. So that's 30 meters per second here, 47 degrees with the horizontal. Now here's a trick when it comes to vectors. Each vectors have their own independent Cartesian coordinate planes. So basically, this is 7 meters per second here. And we can actually translate, it's called translate the vector. Basically move this vector here to here. So now we can say that it's gonna be like that. And 47 degrees here. And 30 meters per second here. Now that's our vector right there. Now here's a trick I want to show you. Show you guys. So now here we can actually apply the tip to tail method here, and this is our resultant vector now. And here, since this entire angle is 180 degrees, the angle that we're going to be referring to here, or finding the angle here, let's say just theta here, would be 353. Because since this entire angle is 180 degrees, so 47 degrees plus x equals 180 degrees. 180 degrees minus 47 degrees equals x. 180 minus 47, 133 degrees. 133 degrees. So now we're going to be using the law of cosines. So you might be wondering, hey, what's the law of cosines? Basically this long formula here. C squared equals a squared plus b squared minus 2ab cosine theta. Yeah, it's pretty long, but you'll get the hang of it pretty quickly. And this is a pretty short method on how to find the resultant vector. So now C is always going to be the resultant vector. Okay, C. A, and for A, it's going to be the one larger than B. So basically we can say that 30 meters per second is A, 7 meters per second is B. So substituting those values, it would be C squared equals 30 squared plus 7 squared minus 237 cosine. And you might be wondering, what's theta? Yep, we solved theta here. Okay, cosine 133 degrees. Now we have to isolate C. So basically just square root that, or square root both sides rather. So C is equal to square root of this long expression here. 237 cosine 133 degrees. Now substituting that into our calculator, it would now be, oh no, I can't see, 30 squared plus 7 squared minus 2 times 30 times 7 cosine 133 rather, can't type it, wow, 35.1488. So now our final vector would be 35.1488 meters per second. That would be our final vector of the frisbee player throwing the frisbee. Yeah, it's a problem about the frisbee player throwing the frisbee. Now to prove that this method is actually correct, let's do the traditional method of using the analytical method and not the law of cosines. So when it comes to vector addition like this, we can basically just separate the vectors into different Cartesian coordinate planes, find their opposite and adjacent sides, or x and y components, then add up those components to get the resultant vector component rather, and use the Pythagorean theorem and use the tangent formula to find the angle. So now we have 30 meters per second at an angle of 47 degrees, and now running at 7 meters per second here. When it came to our previous examples, 7 meters per second to the east, it's just 7. So 7 for the x, 0 for the y. That's our component form. Now we have 47 degrees, and as we can see, it already started from the east portion of the x-axis. So yeah, we don't really need to do anything else. Just substitute it. So magnitude cosine 47 degrees, magnitude sine 47 degrees. Substituting those values into the formula, 47 20.45995. You know what? I'm gonna write the entire thing. Decimals, they bug me. 21.94061105. So yeah, that's gonna be the component form of our vector. Okay, so adding them up, it would be 7 plus that. I'm just gonna try to make sure, because you can never be too safe. Plus 7. Okay, 27.4599508, comma 21.94061105. That would be the component form of our resultant vector. Substituting that into the Pythagorean theorem, equals, so now calculator, 508 squared plus 21.94061105 squared, 35.14. And yeah, it's correct. It worked. Wow, gumana siya. Wow. Meters per second. Wow, gumana siya. So, sorry for speaking in another language, but yeah, it's the same answer. 35.1488 meters per second with the law of cosines. And with the traditional analytical method, 35.1488. It's the same answer, but this one's a shorter method. But also be cautious when it comes to this method. Make sure to first translate the vectors. Okay, make sure to first translate the vectors in a way we can use the tip to tail method. By what I mean by that is what I explained on a previous video. Basically, these are two vectors, right? These are the arrowheads, these are the bottom of the arrows. It needs to be always the bottom of the arrow to the tip of another arrow of vector. It can't be like that. It could be like this. Could be like this. It'll still work. It'll still work no matter what. When it comes to two vectors, okay, keep that in mind. Two vectors. Because why? Okay, I'll show you why. So now here. Basically, imagine these are two vectors here. Now, two vectors will always follow the layout of a parallelogram. Now, parallelogram meaning two of the opposite parallel sides rather are congruent. So this is congruent with this one is congruent with this one as well. So as I told you, that even though the vectors are gonna be like this, it's gonna be the same. Okay? It's gonna be like this, or it could be this. It can't be from arrow to arrow here. That won't work. It could be like this. It could be like this right here. They'll always be equal. So yeah, it's a property of it. And of course, as you can see, it's actually correct. Thanks for watching that one.